So now we're going to go from email to love. Vaclav from eHarmony.
Hey, good evening, everyone. Thanks, Matt, for having me. I'm a director of machine learning at eHarmony, based in Santa Monica. And I would like to tell you how we use machine learning to match people. So, because we are a bit short on time, you can also tweet your questions at me, and I will answer them afterwards. So, to match people effectively, we are basically solving three separate problems. The first one is we try to find people who are compatible for long term. Yeah? So that means like 20 years down the road, they will still enjoy doing things together, as opposed to, killing each other if they are in the same room for too long. So this is what we call compatibility matching. It's about the personalities, about the things that are very hard to change about ourselves over time. But, even if two people have fantastic personalities and would get along very well, there is no guarantee that they will be physically attracted to each other. They will have similar interests. They will be interested to talk even. So that's what we refer to as affinity matching. And finally, we need to decide who we introduce to who and when. So that's distribution. And I'll talk about all of these in a bit more details, and I will start with the compatibility matching. The stuff that predicts long-term marital satisfaction, these are not the things that generally get discussed on the first date, or these are not the best pickup lines. So that's why we ask our users quite a lot of questions. That some of them might be like, how do you agree with the statement that people often let you down if you depend on them? I mean, not the best pickup line. So we ask a lot of these questions, and we also ask these questions to a representative sample of US marriages, and then we build models from there. We ask actually about 150 questions these days, which give us a very good snapshot of the personalities of people. And so initially, the model was done that on these married couples, we had them answer many more questions and did factor analysis on that, and they discovered some dimensions that are predictive of marital satisfaction. So to give you an example, one of these dimensions that's quite predictive is obstreperousness. So here on this chart, you can see a sample of several thousands of marriages, and each dot is a marriage. The blue ones are happy marriages, and the red ones are less happy, distressed marriages, where the two people are talking about divorce, and they are not very happy, not spending much time together. And you see, this is obstreperousness of female and of male, and the more obstreperous people are on the right and to the top. And already from this one dimension, you can see that, if I know how obstreperous these two people are, I can make a guess or, build a model that will predict the probability that they will be happy or not, right? And we have actually quite a few of these dimensions. The initial eHarmony model had about 29 dimensions, but over time, as we are collecting more and more data, the models are getting more complex. And all these dimensions together, we basically build a classifier, which, or predictive models that tells us what is the expected happiness of a marriage if these two people were interested in each other enough to get married. So, and we use these models to predict for two people who haven't met each other, how likely they are to be happy. So here is a distribution of marital satisfaction. So this is actually the distribution over existing marriages. But we use our model that has been trained on this data to predict for two people who haven't met, how happy they would be. And we only introduce them if they fall into the upper quartile, if there is a very high probability that they will be in the upper quartile in terms of satisfaction. So that's the compatibility part. And as I said, there is no guarantee that the two people will be actually attracted to each other. For example, here you have some pairs of people who might be psychologically compatible in terms of their personalities, but, sometimes the age difference is a little bit too much. Or, the two people are living on the other side of the planet. So even if they are made for each other, they will just not make the flight. But other times, the people are actually interested, in each other and mutually. That's what we are looking for. So we can still see them on the side where they exchange messages. And if both of them send messages there and back, that's sort of an expression that they both like each other mutually. And we want to make as many matches as possible that look like that. And so to do that, we use everything that we know about our users, right? So we have quite a lot of data explicitly. We know their religion, ethnicity, marital status, like are they divorced, widowed, or are they single? We know what kind of devices they are using. Are they on mobile, on desktop, laptops, etc.? And we also have their communication history, because most of the initial communication, at least, happens on the site. So we know who they contacted, or who responded to them, etc. So this is very predictive as well. So to give you some examples, for example, let's have a look at distance. So here on the x-axis, you can see the distance between the two people. And on the y-axis, I plot the probability that they will be mutually interested in each other. So you can see that it's falling off. It's falling off actually quite steeply because the x-axis is on a log scale. So in a normal scale, it falls down much quicker. And by the time we get about 60, 63 miles, the probability has sort of starts to plateau, right? So to people, it seems empirically that it doesn't matter that much whether it's 60, 70, 80, 100, 500 miles. Because anyway, like, you need to wait for the weekend at least to see each other. And already just this one feature, like on distance, I mean, it makes sense to match people who are closer together, right? They might find it more plausible that they will see each other. So here, distance 0, that means that they basically live in the same zip code. That doesn't mean the same household. And another feature that's predictive and that people care about is, for example, height difference, right? So here I plot the height difference male minus female. So, the vertical line, that's where they are the same height. And you can see that the highest probability of communication between two people is when the height difference is between 4 to 8 inches, when the male is 4 to 8 inches taller. Doesn't mean like it will, nothing will happen if it is the other way around, but you see that empirically users seem to prefer or have the highest probability of getting into communication when the difference is this, 4 to 8 inches. And so, again, you could build, a model and maybe match people just by height, right? Food preferences matter. So we ask people also about their food preferences. This is not part of the initial questionnaire, but later on as supplemental. And you see the people who eat healthy, who eat varied, junk food, gourmet, or vegetarians. And here you can see on the diagonal that, there are 3 big numbers which are green. So that means that, the healthy people generally get along quite well with healthy people, gourmet people as well. And for vegetarians, this is the biggest positive lift versus like a normal average match that we make. There is not many vegetarians in the system, but, when they find each other, they are pretty much unstoppable here. So on the other hand, people who report that they eat junk food, they don't, have much success with anyone else. And especially bad it is, if the 2 people who are junk food eaters are matched together, right? Obviously, the user profile pictures are a very rich source of information. Like any one of us, if you look at a picture of someone, we can make, some deductions of what kind of a person that they are. You can see what their, I don't know, even you could estimate education, income, obviously attractiveness and other things. But a lot of things that matter are a little bit fuzzy. It's very hard to write a program that programmatically will arrive at the same judgment as a human, right? People, when we were interviewing them, were saying, "Oh, I care whether that person is like sort of trendy, hip, or cleanly dressed," or very hard to write a classifier for that. But what you can do is you can run just a face detector, and you can basically calculate the ratio of the size of the face towards the whole picture, and that gives you sort of a proxy for what kind of shot it is. Is it like a picture where I can see both the face and the body, passport photograph, something from very close or from very far? And when you look then, you actually find that the pictures that have most success in terms of com initiations, which they receive, It's like when you actually see the face and the whole person. The passport photos are doing quite well. My picture over there wouldn't do very well because it's taken from very close. It's not a very flattering angle. And the last one, you cannot tell who it is, actually, right? So this is a big turn-off on a dating site, especially for women who don't see who that is. It feels very dangerous to go and meet them for a date. So, these are just a few of these features that are predictive individually, right? And so what we are doing is we have this data on about 40 million users who have registered on eHarmony, since the beginning. And we know all these attributes about them. We know thousands of things. And we also make a lot of matches every day. And pretty much immediately we see whether, it is working out or not, whether they communicate or whether there is nothing happening, which is sort of a negative signal for us. And we use this to build models. And we build models that predict then for two people who haven't been introduced yet whether they would talk. So we use these, attributes directly, but we also pre-compute some features because, from some domain knowledge, that these kind of features might interact in a way, so you can pre-compute that. For example, if someone says, I'm willing to drive 100 miles, and that person is 105 miles away, you can say, okay, his requirement was violated, so there is like a flag for that. You can also run unsupervised learning, different types of clusterings or topic modelings like LDA. Classifiers can label people as like someone into cooking or outdoors, etc. And then we build these models. There is quite a bit of machine learning that goes into that. You want to L1 regularize these models so that they are like not gigantic, not only that they generalize better, but also so that you don't pay the cost for fetching all these features, which might be very negligible impact. And then it might slow down your production. So in terms of our setup and tools that we are using, we have like a modeling box, which happens to have 1 terabyte of memory, which is nice. That sits next to a Hadoop cluster. So we have a Yarn cluster for the embarrassingly parallel data processing, crunching, preparing the data set, etc. And we have also access to all this, to the clickstream of the data, clickstream of the users on the website, their profile pictures, the matches that we have done in the past. And in terms of tools that work well for us, our workhorse is Vorpal Wabbit up there on the right, which came out of Yahoo Research. John Langford wrote this open source learner. He's now at Microsoft Research here in New York. And then what we use is Hive for the data massaging, Impala also for some quick analytics, and RStudio server, which actually when it runs on this big box machine, it allows us to share it between the whole team. And we use like GBMs for, because the Vorpal Rabbit builds basically generalized linear models. We use like GBMs in RStudio. And then we had some good luck with Eureka, which is sort of a genetic algorithms, package, which actually happens to help over even the more sophisticated algorithms. It finds interesting features that when added into these simpler models, help. So finally, for match distribution, we need to decide who to introduce to who, when, and we don't want to overwhelm people, right? We don't want to dump, hey, here is 50,000 people compatible with you. Like, there is no way you are going to get to know each other, one of them, and decide who is the right person. So we want to give people enough options so that they get engaged, but we don't want to overwhelm them. So let's say for the case of heterosexual matching, you have women on one side, men on the other side. You are matching between these two groups. So basically, it's a bipartite graph where some of these edges are missing. Like some of these edges have been killed by our compatibility system, which says like, no, don't introduce these people because there is not high enough chance that they will be very happy in a marriage. So we have, from the compatibility system, we basically get these edges which are allowed for the system to make. And we also have a set of constraints, right? So let's say for illustration here, that I want to make 2 matches to everybody. Yeah. And I don't want to, because I don't want to introduce one person to everyone because they are not going to marry everybody. So, and if someone gets too many matches, they will be overwhelmed. So the way you can solve this is that you basically imagine this as a series of pipes, and where these edges have a capacity of 2, or whatever is that match limit over there. And here the edges between the users have capacity of 1. And then you can just pump water through that. And what you will see is that the matches where there is some water flowing are the matches that you can deliver given these constraints, right? So the solution, it's like a flow problem, and this delivers you the maximum number of matches that you can deliver given these constraints. However, we don't want to just maximize the number of matches. We also want to do the matches that have the highest quality. So there is a formulation as a transportation problem where you can specify also sort of costs on these edges. So this would be the probability that they will like each other. And then when you run this through a solver, you basically get back the matches that you can make, and you maximize the expected number of communications in the system, right? So, I mean, to answer your first question is, like, how do we know that this works, right? So we regularly ask Harris Interactive to go out and make a survey for us of marriages and then count how many of them originated on eHarmony, etc. And recently we had some larger collection of data, and we gave it to researchers who have published a study in Proceedings of National Academy of Sciences. So this was a team of Professor Katsiopo. And Proceedings of National Academy of Sciences is one of the top-rated interdisciplinary journals. This has been covered quite a bit, during the first 24 hours. And for eHarmony, there were some interesting results from there, and quite encouraging. So one thing is that between the online dating sites, about the largest number of marriages originated on eHarmony, right? So even though we don't have the majority of people overall, but in terms of the number of marriages per user, we seem to be doing really well. So about a quarter of all the marriages from online dating had met on eHarmony. And actually, interesting number is that 1 in 3 marriages in this period, so that was from 2005 to 2012, met online. Yeah, so that was another surprising number, even though I'm working in this area. And finally, what we are also looking at are the breakup and divorce rates. So this was a study which had people who got married between 2005 and 2012, right? So this is a relatively short period of time, and also it's relatively recent. So this is 5 to 12, so that's 7 years, but on average, these people were married for about 3 to 4 years. So that's why you are seeing here like relatively low divorce rates compared to like the often, advertised 50% divorce rate, because there is really not that all the time to age all the marriages. And the encouraging thing here is that basically the couples that met on eHarmony also had a low divorce rate, so nearly half of what the marriages that met actually offline. So thank you very much. I'm happy to answer your questions. Thank you.
Great. One question here. Actually, why don't I give you my mic? Name and company, please.
Hi, very good presentation. My name is Misha Sobolev. I'm with Actionable Information Advisory. Just a quick question. So I understand that eHarmony works on a subscription-based model. So the better you are, the algorithm, the sooner they stop becoming a paying subscriber. And the question is, do you compensate somehow for this, or do you try to get word of mouth, so to people who got married and are happy to refer their friends? How do you work around that problem?
Yeah, very good question. I mean, so the thing is that the word of mouth is very strong. So, for anyone, if everyone came in and just on the first day they got married, they would tell everybody and we could charge a lot of money, if that was this quick. Typically, the process is a little bit longer because the users, when they start online dating, they still don't know exactly what they are looking for. So they want to look around, meet a few people, and a lot of people are not really ready for a relationship. So we actually sell a lot of long-term subscription plans. Like a lot of our plans are 1 year. We sell even some 2-year plans. So right now, it is not really an issue that people would find someone too quickly. And that's not necessarily just because the technology wouldn't be able to give them the best matches. It is more about the people not being ready and because it takes time to the users. Thank you.
Just how big is the team out of curiosity?
Sorry?
How big is the team?
So eHarmony has about 200 people in Santa Monica. We have a few offices around the world. And in terms of technology, we have about 50% tech. But still, like, a lot of people are building the site, infrastructure, and so on. So matching is about 20-ish people. But that still includes even people who are working on the infrastructure scaling, delivering the matches every day. So we have about, like, below 10 people who are working on this product side, on the machine learning, data science and statistics. Yeah.
Hi, Margaret Ost. My URL is fraudfinding.com. Is eHarmony outside of the United States right now?
Yes. So we are providing service in Canada, and then also Brazil, United Kingdom, and Australia.
And my follow-up question to that was, do you notice a difference in some of these statistics?
Yes. So definitely there are differences in like what is the culture. You can get people, even if the underlying psychology was the same, if you ask the same questions to people, let's say in UK versus in the US, you might get slightly different answers, even if if it was the same person, because maybe it's not a habit to present things the same way in UK. So what we do is whenever we were rolling out in a new country, we first redo the compatibility model. So we take a new sample, a representative sample of marriages, and we have specific models for that locale in terms of compatibility. And then on the large-scale machine learning side, we also have separate models for like Americas, Europe, and Asia. So we see differences. There are a few infographics, I believe, out there about some of the funnier differences between the countries. Yeah. Thank you. Question.
Andy Beveridge, I'm at socialexplorer.com. I was curious about, have you done any analysis of the differences? You showed differences between eHarmony matches, other online matches, and offline matches. But I mean, isn't there some selection bias? I mean, if you subscribe to eHarmony, or if you say subscribe to Match.com, or if you, go to the art museum to look for somebody, I mean, wouldn't it be different? Aren't there different characteristics? Have you looked at that at all?
Yes. So this study, I haven't done this study, which was in the Proceedings National Academy of Sciences. That was like independent academic research, which was done on data that we commissioned from another independent surveyor, Harris Interactive. So they are looking at differences, and they are trying to control also for demographics, and the background of the people. These differences in divorce rates are staying even if you control for these things. But there definitely is an aspect to that, and I would liken that to, for example, like someone goes to Harvard, right? Is it because and people who go to Harvard might make more money than people who are not going there? So is it because they went to Harvard, or is it a self-selection, bias? The same thing, are people who care more about their relationship coming more often to eHarmony? I would argue that yes, and that is part of the differences that we see. Yeah, and so this kind of results that I was showing, this is sort of like testing it as a black box end-to-end, right? We also do A/B testing on things, initially partially inside. But this is very hard to disentangle because I don't think there are even studies about like Harvard, whether they are actually contributing and making those people more likely to make more money or not.
Well, actually, there have been.
Have been?
Yeah.
So, and it shows conclusively that like it's worth it or not? No. Okay. It's very interesting.
It shows exactly that. It shows that, in fact, Harvard is probably just what you're saying, it's self-selection.
Yeah,
For Harvard. In fact, there was an article today in the Times about ratings of universities, and the person, I can't remember her name right now, who's the leading person who studies this, was arguing that you can't really use the ratings of, like, various ratings among colleges because of exactly this problem.
Okay. Yeah, I guess this is a difficult thing to ascertain unless you do really randomized trial, which is a bit tricky, right? Because like I divide you guys into two halves, and you will go on eHarmony, and you guys need to find someone else elsewhere. It's very hard to enforce this in real life. Yeah, there's a.
Hold on.
Michaela, Oracle BI consultant. Jumping off that, isn't it like more your foundation like of your model, matching model, is more like communication types?
Communication types. So, I spent a little bit more time, I guess, on the large-scale machine learning, which is based on, we want to get people talking, right? Because this is a prerequisite for them to go on a date and then, eventually get married. But the compatibility part doesn't have anything to do with the communication. That's really based on, well, what kind of personality are you, what kind of personality the other person is. Are people like you guys, in happy marriages or in unhappy marriages? So there is definitely, communication is important in a marriage, right? And that contributes to, the marital satisfaction there. So if you have two people who are very bad communicators, they probably shouldn't be together.
Set would be like just raw data. And then when you ask about the food and how they feel, and like strongly or neutral or low, that's where the communication types model comes in, correct?
Sorry. Yeah, I'm not sure I completely understand.
It was like in the beginning
Maybe
of
we
the
can
slide.
discuss afterwards. Yeah.
Yeah, we should. Actually, we should probably wrap up. So you're going to be here as well after.
Yeah, I'll be around. So
Okay.
guys,
All right.
come talk to me.
It's going to be a big conversation fest.
Thank you. Thank you.
Thank you.